Swayam Prabha. Digital India. Educated India.
Welcome back. So, beginning this lecture, we are going to see this problem of pipe flow, and this is the exact same point where we stopped our last lecture. So, there are several steps. I have mentioned this to you before, that if you follow these steps carefully, you will be able to tackle all the problems that are related to dimensional analysis. So, the step 1 is you have to list all the variables that are involved in the problem. Okay? In our case, we know that listing the variables was, one is pressure per unit length, something that needs to be found out. Then there is a diameter d, there is the density rho, then there is viscosity mu and the velocity v. So, first step we have done, we have listed all the variables that are involved in the problem. Second step is we have to express each of these variables in terms of basic dimensions. Very simple to do. So, we have to write down the dimensions of all these 5 variables. So, velocity is Lt minus 1, all right, here. Mu is Fl minus 2t, okay. So, delta PL is Fl minus 3. These dimensions, if you recall, we had written some slides ago when we were trying to explain it through experimental procedures. And the d is L, and whatever remaining, it is rho, it is Fl minus 4 t square. So, this is step 2. Okay. After that, we have to determine the unique number of pi terms. So, what we have seen, the unique number of pi terms. Okay. How? So, going to tell you now. First I will tell you and then do on the. So, first we have to know what is k, correct. K is total number of variables. So, in our case 1, 2, 3, 4, 5, right, or we can count here as well 1, 2, 3, 4, 5. So, k was 5, right, and what are minimum number of reference dimensions that are there. So, that you can see by looking at the dimensions of this variable. So, we have length L also is there, T is also there, F is there. Is there any other term? All these 5 of these terms has basic dimensions length, T and F, FLT. So, that means suppose if there was no F in any of these 5 variables, then reference dimensions could have been 2. Here L is also there, T is also there, F is also there. So, R will be 3. So, number of pi terms is going to be k minus R according to the Buckingham pi theorem. So, 2 pi terms. Okay. This is just to explain you. Okay. So, the step 3 says determine the required number of pi terms. So, in this particular case, the basic dimensions are F, L, T. Okay. So, that means basic dimensions are 3 total, same thing what I have written before. Then the number of pi terms are the number of variables 5 minus the number of basic dimensions 3. So, there should be 2 pi terms for this case. We have already written it and seen it. All right. So, 3 steps we have done. First step was determining writing all the variables, second writing their dimensions, and third determining the number of pi terms. This forms very crucial first 3 steps. Okay. Now, step 4, we have to select a number of repeating variables, where the number required is equal to the number of reference dimension. So, repeating variables will be equal to the number of reference dimension. In this case, we have how many reference dimension? 3. Okay. So, number of repeating variables that will be there in all the dimensionless pi terms will be 3, I mean repeating variables. So, 3 repeating variables, and this will depend upon 3 repeating variables for this case, not always, okay, for this case of pipe flow. And why? Because the repeating variable should be equal to the number of reference dimensions. In our case, it is 3. All right. So, we choose 3 independent variables as repeating variables. So, this is also important. So, those 3 repeating variables should be independent. One cannot be obtained from the other. Okay. There can be more than one set of repeating variables. Okay. So, one set of repeating variables must be 3 independent variables. All right. So, you cannot have both, for example, mu and nu as repeating variable. All right. For example, or gamma and rho, you should try to avoid these type of repeating variables. Try to avoid. All right. Now, in our this pipe flow case, we have chosen repeating variables as, we had 5 variables, right, delta PL, we had mu, we have diameter, we have velocity, and we have rho. So, this 3 we have chosen as repeating variables. Okay. We note that these 3 variables by themselves are dimensionally independent. So, this is an important criteria, which, I mean, what does this dimensionally independent means? You are not able to form a dimensionless group with them alone. So, you cannot in no way, if you choose D, V and rho, you will be able to form a dimensionless group. So, they are dimensionally independent. Okay. That is one of the important criteria of choosing a repeating variable. All right. So, now the step 5. So, step 4 was, we have to select the number of repeating variables. We have chosen that. Now, step 5 is, we have to form a pi term. Now, how is that is formed? We have to form a pi term by multiplying one of the non-repeating variables by the product of the repeating variables, each raised to an exponent that will make the combination dimensionless. So, this means now, in our particular case where we had 5 variables, pressure drop per unit length, mu, d, rho and v. We chose 3 as repeating variables, which means we were left with 2, correct. So, first pi term will be formed by multiplying one of these. So, out of left 2 we will multiply 1. So, we will see which we so we have d, v and rho. So, we have delta PL left. So, this says the first pi term pi 1 is going to be multiplying one of the non-repeating. So, I am multiplying delta PL multiplied by product of the repeating variables. So, d to the power a, v to the power b and rho to the power c, something like that. Okay. I mean, we will see exactly how I have done in this slide, but yeah. So, but the main message is multiplying one of the repeating variables, one of the non-repeating variables. So, which is this pressure drop per unit length by product of repeating variables and each raised to power of an exponent a, b, c, which are still unknown. So, this is how we are forming one pi term. Similarly, we can form the second pi term as well. So, out of the, in this case we multiplied only 1, for the second pi term you can multiply the other left one. So, as I did, so pi 1 is going to be delta PL d to the power a, v to the power b, rho to the power c. All right. Now, this product should be dimensionless, correct, that is the purpose. So, this should be dimensionless, all right. So, we need to solve for these exponent values. How? So, simply what we have done here, so we have written the dimensions of del pressure per unit length, right, because we wrote the dimensions of each of these variables, d to the power a, that means L to the power a, all right. V is LT minus 1, so V to the power b, and rho is FL minus 4 T square, and this to the power c should be having no dimension. So, no dimension means f to the power 0, L to the power 0, T to the power 0. Normally, how would you solve that? You will collect the powers of f and equate it to 0. You will collect the powers of L and equate it to 0, and you will collect the powers of T and equate it to 0. All right, we will see. So, step 5 is still continuing because we are forming the, so you see, I will just take, so f appears here, so f to the power 1 and f to the power c. So, this will be, there is only 2 f's, so it will become 1 plus c is equal to 0. For L, it is going to be minus 3 plus a plus b minus 4 c is equal to 0, and similarly for T, minus b plus 2 c is equal to 0, but we have written it here in a much. So, see, 1 plus c is equal to 0, this will give c as minus 1, all right. So, b is equal to 2 c, this implies b is equal to minus 2, right, and if we know c and b, we can get a here, okay. So, solving these things, we get a is equal to 1, b is equal to minus 2, c is equal to 1, as we have already found out here, all right. So, this will give us, so if we put back a, b and c in that dimensionless group, pi 1 will become delta PL into d divided by rho v square, okay. So, now, so first dimensionless term we have found out. So, now there is only mu that is remaining, that is non repeating variable. So, in similar way we can form another group. So, we form another group where we have mu d to the power a, v to the power b, rho to the power c. Okay. One important thing to note, that this a and this a are not equal. So, actually we can write a star, b star or c star, so that you do not get confused, but we have to solve in a similar way. This a, b, c will be different from what we have obtained for pi 1. Do not simply substitute a, b, c that is obtained from the first dimensionless group. It is a new a, b, c, small a, small b, small c, very important to note. So, we follow the procedure again. So, this was mu, right, L to the power a, v to the power b, rho to the power c is equal to f 0, L 0, t 0, correct, f to the power 0, L to the power 0 and t to the power 0. So, if you solve this, we are going to get a is equal to minus 1, b is equal to minus 1, c is equal to minus 1. So, 3 equations you can obtain, right. So, if you see, so it will be same, 1 plus c is equal to 0. So, f is from here and f is here. So, if you start collecting b, so it will be 1 plus 1 minus b 1 minus b plus 2c is equal to 0, right. C we have already obtained. So, 1 minus 2b minus 2 is equal to 0. So, if you take 2b 1 minus 2 is minus 1, and this is what we get. And similarly for b, so minus 2, right, plus a plus b minus 4c is equal to 0, and this is going to give us a also as minus 1, all right. But anyways, I will rub this, and you can see if we solve this equation, we are going to get a is equal to 1 minus 1, b is equal to minus 1, and c is equal to minus 1, all right. And our new dimensionless group is mu by dv rho, all right. And is this term does this term look similar to you? One by Reynolds number. Okay, we will come to that. Now, the step 6 of a general procedure is we have to repeat the step 5 if there are more number of repeating variables that are left. So, we have to repeat step 5 for each of the remaining repeating variables. There will be cases where you will not get only 2 dimensionless group, but let us say 3, 4, 5, depends how many. In another way, we could also have chosen d, v and nu as another repeating group, okay. Fine. I mean, it is not only that we had to choose the one that we chose before. Instead of rho, you could have chosen mu as repeating variable, and rho could have been chosen as non-repeating variable. The one, I mean, delta PL here which was to be found should always be in a non-repeating variable, otherwise your equation will become implicit, and that is what we do not want. If there is something on both on the left hand side and the right hand side, it does not help. So, the best thing to do is to keep the dependent variable as one of the non-repeating variables. Now, the step 7 is you have to check all the resulting pi terms to make sure that they are dimensionless. That is an important step. So, here we check again, we actually have done the same steps and same checking of this term in this last lecture. So, we can see pi 1 is f to the power 0, L to the power t to the power 0, and similarly this is also 0. This is step 7. Okay. So, both pi 1 and pi 2 are dimensionless. Now, in the end, express the final form as a relationship among pi terms and think about what it means. So, the final step is pi 1 is a function of pi 2 comma pi 3. Here we have only 2. So, we can simply write pi 1 is a function of pi 2. So, pi 1 is a function of pi 2. Okay. Or we can simply write in a reverse format as well, d delta L rho v square is equal to, if this is dimension, so 1 by this is also dimension. So, we have written this, and this is, as I told you, is a Reynolds number, all right. So, important message here is pressure drop depends on Reynolds number, and as you see we have obtained this result, an important result, that the pressure drop depends on the Reynolds number using dimensional analysis. So, I hope at this, by this point in time, you would be appreciating how powerful dimensional analysis can be. For future, aspiring experimentalist, this is one topic which you must understand, otherwise it is impossible to carry on the experiments. All right. Now, there are some rules or guidelines for choosing variables for Buckingham pi theorem. So, one of the, as I said, one of the most important aspect of dimensional analysis is choosing the variables important to the flow. However, this can be very difficult. So, in a very big problem, large problem, there could be many variables. Now, the challenge is how to choose the variables which are more important to the flow than the other. Okay. The guideline is we do not want to choose, we should not choose so many variables that the problem becomes cumbersome. If we choose 100 variables, then the problem will be large, I mean, it is very difficult to even solve it using dimensional analysis. So, to be able to do that, we use engineering simplifications. Okay. So, what does this do? We obtain in this first order results, okay, sacrificing some accuracy, but making the study more tangible. Okay. So, while choosing these variables, we have found out that most of these variables will fall into one of these three categories, most of them: geometry, material property and external effects. So, best is to choose carefully. So, all the variables should be falling, but this is only guideline, every problem is different, but more or less majority of the problem will satisfy these. External effects, what are external effects? External effects denotes a variable that produce change in the system, like pressures, velocity or gravity. These are external effect. So, by definition, it denotes a variable that produces a change in the system. What are material properties? Material properties, it binds the relationship between the external effects and fluid response. For example, the viscosity and density of the fluid can be listed under material properties. Geometry, it is the lengths and angles, usually very important and obvious variables. These are most common one. You cannot neglect that. For example, the diameter of the pipe in our case. Okay. As I said, we must choose the variables such that they are independent. There is no point in choosing all these three, mu, nu and rho. We should not be choosing all three of them. We can either choose nu or rho, or mu and rho, or even in some case mu and nu, but preferably mu and nu and rho. Because why I am saying this? Because these are not independent, is equal to rho into nu. This is the formula, right? So, because of this relationship, they are not independent, all three of them, for instance. So, F P Q R U V W is equal to 0. This is one equation, and Q can be written as F1 of say U V W, for example. Then U, V and W are not necessarily in F if they only enter the problem through Q, okay, or Q is not necessary in F. So, we must not put it in both places, all right, both in F or Q, sorry. So, that is one of the other way of saying that it should be independent. So, either you enter the variable u, v and w through Q, or enter it through F here, okay, in this one, all right. So, we will start with a question, another question. So, the time period t of the water surface waves is known to depend on the wavelength lambda, depth of the flow d, density of the fluid rho, and acceleration due to gravity g, and surface tension sigma. So, using the Buckingham pi theorem, obtain the dimensionless form of the functional relationship. This is a classical problem of Buckingham pi theorem, which we are going to solve in the class today. All right. So, first we write down all the variables which already have been given. It says time period t, that is how we have t. We have to find out t, and it is known to depend on the wavelength lambda. So, lambda is here, depth of the flow d. It is our good luck that we already have been told what variable this time period depends upon, and so t is not only non-repeating variables, we will see later, but also something that needs to be found out. That is why we have written t as a function of. So, going back again, the time period t depends upon wavelength lambda, we have already ticked it, depth of the flow d, we have already ticked it, density of the fluid rho, acceleration due to gravity g, and the surface tension sigma. So, if you see how many terms are there, 1, 2, 3, 4, 5, 6, all right. So, total 6 variables are there. Second step is listing all the dimensions, and that is going to be, so t is time period is time period t, right. Lambda is, so this is actually lambda is wavelength L, okay, and the depth of the flow is also L, rho is the density of the fluid. So, it can be what we have chosen, we have chosen the basic dimension as m, L and t. So, sorry for this typo, this should be L, okay. Rho is m L minus 3, g is L t minus 2, and surface tension sigma is m t minus 2, okay. All right. So, as we have seen 1, 2, 3, 4, 5, 6, the total number of variables is 6. So, n is equal to 6 or k is equal to 6, and number of primary dimension m is equal to, we had been calling in Buckingham pi theorem k, and r is 3, okay. So, number of pi terms will be k minus r. So, total 3 pi terms. So, some of our steps are complete. We have determined k 6, r as 3, and therefore, number of pi terms is going to be 6 minus 3, 3. These are some very important steps. This must be followed. All right. Now, we have selected, we have to select a repeating variable. So, we have selected lambda, g and rho as repeating variable. Okay. So, if we have, so that is why first because if there are 3 repeating variables, okay. So, pi 1 will be multiplied by say first non repeating. So, t multiplied by lambda to the power a, g to the power b, rho to the power c. Okay. So, this should be dimensionless pi 1. So, we have written down the dimensions m to the power 0, L to the power 0, t to the power 0. T is t, this t is t, lambda has a dimension of L. So, L to the power a, g has dimension of L to the Lt to the minus 2. So, therefore, it is Lt minus 2 to the whole power b, and rho is ml minus 3. So, ml minus 3 to the power c. All right. So, if we solve this, we get 1 minus 2b. Why? See, we have done m, no, we have done t. So, t, so we have equated the coefficient of t, 1 minus 2b is equal to 0, this gives b is equal to half. Secondly, we have C is equal to 0 is what we get. Okay. If we compute the so B is equal to, and we have to calculate A plus B minus 3C. So, actually we should be, so the other term is going to be, so A, so we will calculate B, so it will be B minus so how are we going to get this C is equal to 0? We equate m to the power 0. So, m is only in one term, right. So, m to the power C, therefore, C is equal to 0, and to equate, we have to do for L to the power. So, it will be A minus A plus B minus 3C is equal to 0, correct. So, this has been gotten for equating exponent of t, and this has been by equating the exponent of m, and the third equation by equating the exponent of L. Okay. So, so we get B is equal to half, C is equal to 0 and A is equal to minus half. So, our first term is going to be T under root G by under root lambda, all right. Now, the second pi term is d lambda to the power A, G to the power B and rho to the power C. So, these repeating terms are the same, of course, exponents we will recalculate. So, we are going to recalculate now, because this is not the same, and instead of T we have put D, all right. So, by inspection it is easy to see that, I mean, if you do the same analysis as this, you will find out another pi 2 term as d by lambda. Please solve, okay, at home, all right. The third is going to be the third repeating variable, non-repeating variable sigma, that is the surface tension, and lambda to the power A, G to the power B, rho to the power C, and this will same procedure, sigma dimension, this is L is lambda, this is G and this is rho, and we calculate it, we can get C is equal to this seems to be a problem 1 plus, so we have done m 1 plus C. So, C will be minus 1, sorry for and then this is equating m, exponent of m, L will be, so we are going to equate T, so minus 2 minus 2b, okay, and this gives us B is equal to minus 1. So, this is equating T, and now if we equate L, so L to the power A plus B minus 3C, and this will give us A is equal to 3C minus B. So, 3 into minus 1 minus, so that will become A is equal to minus 2. So, this is also correct. So, I will just sorry for the error here, but the calculation C should be minus 1, and this is computed by equating the exponents of L, all right. So, pi 3 is sigma by lambda square rho G. So, this is another pi term. So, we have found out pi 1, pi 2 and pi 3 using this Buckingham pi theorem sum steps. Now, the last step is expressing pi 1 or any pi's as a function of the other two. So, this is our final result. Okay. So, I will like to close this lecture at this point and we will proceed in our next lecture. Thank you so much.